Hello, college algebra student. This video is for chapter 2.6, part 3. We're still solving other equation other than linear and quadratic. And the last one that we're dealing with, is it the last one? Yeah, I think it's the last one, is absolute value linear equation. So what is absolute value linear equation? That means your unknown x is trapped inside an absolute value. So again, if your unknown is inside, you cannot, this absolute value is not the parenthesis where you can, we distribute something and, and combine like terms. So if you have something inside the absolute value, they stick inside, they are trapped. You cannot break it with the outside. So you can combine like terms with the outside. So how can I solve it? How can I solve absolute value equation? So the idea of absolute value is actually measuring a distance. If I write absolute value x equal to 5, that means the distance of x to 0 is 5. So how far, what two number that is distant 5 from 0? So that is -5 and 5, right? So when you have these kind of equation, this is just 1x, then you have a positive and a negative distance. So we would use the same idea. So absolute value is a distance. The distance can only be positive or 0. If there is a absolute value and is equal to a negative number, there's no solution because you cannot have a distance being negative. So when you have a absolute value equation, the first is to isolate the absolute term. So get rid of anything that is outside, multiply or add and subtract, but leave the absolute value untouched. And then to see what it is on the other side. If the other side is less than 0, then there's no solution. If the other side is 0, then that means it is just equal to 0. This term is equal to 0. It's actually equal to 0. You have one solution. If it's greater than 0, then you would say, well, I have two numbers, one positive and one negative. You would split the equation as ax plus b equal to c and ax plus b equal to negative c. So this is the only way you can break up the absolute value lines. So let's look at this this two equation. The first is absolute of 3x plus 4 equal to -1. So never do -4 stuff because this is trapped inside. The first is to look at, do I have this isolated? I do, because I only have one absolute equal to a number. Now I check for the c. Is this a distance? -1 is not a distance. This is less than. A distance has to be greater than or equal to 0, but this is a negative. So all of a sudden you will say no solution. I cannot solve anything where the distance is negative, right? So don't even try to split it into anything. Example 2 is an absolute value, -7 equal to -2. So do you worry that, this is also -2? No, because I haven't actually do the cleanup. So when I have 3x plus 1 minus 7, I have to get rid of this so that the absolute value is isolated. Now, the cleanup is not doing the inside and outside because this is trapped. The only one you can do is to the other side. So you leave the absolute value on one side, and you would be doing -2 plus 7, that's 5. This is a valid distance, right? Whenever you look at absolute value, it's about a distance. How far away is 3x plus 1 from 0? It's 5. So now I can split it into kind of like you do the product. 3x plus 1 is equal to 5. You see how I don't write the absolute anymore? And 3x plus 1 equal to -5. So that's how you split them. And then you just solve the linear one. 3x minus 1 is equal to 4. X is equal to 4 over 3. And for this side, you do +1. No, you do -1. So 3x is equal to -6. x is equal to divided by 3, divided by 3, negative 2. So you have two solution, x equal to negative 2, x equal to 4 over 3. So that's how you solve absolute value equation. Oh yes, we have the last one. The last one is also not a quadratic, not an absolute value, not radical, but it's called equation in radical form. What is equation in radical form? That means you have two groups of stuff in the equation. Either x to the fourth and x squared, but they are square of each other. Or you can have two groups of a plus b. So they're square of each other. So let's do the x fourth and x to the fourth and x squared term equations. Okay, so to solve this equation, you use u substitution, because x squared, x fourth is the square of x squared. X fourth is the square of x squared. So if we replace u by x squared, then x to the fourth will be u squared, right? Because this is the square of the one that you're replacing. And then it becomes a quadratic equation of equation u, and you can solve. Okay, but you will solve it by later. After you finish solving it, you have to solve one more step of x squared equal to u. So let's take a look at this example. This equation is not a quadratic. Why? Because the highest power is x to the fourth. It has three terms, so I cannot do factoring. I cannot do it by grouping. So what I would do is I would use substitution. It is a quadratic form equation. Use substitution. The substitution go like this: u squared is x to the fourth. U is equal to x squared. So you replace this by u, you will replace this by x squared. So now it becomes solve u squared minus 8u minus 9 equal to 0. Now this is a quadratic, right? So quadratic, we have a lot of method to do. What is it? We can use factoring. And this is 1u squared, so I can just do the simple diamond, right? Negative 9, oh no, negative 9 multiply, add to negative 8, 9, 1, right? Negative 9 times 1 is negative 9, negative 9 plus 1 is negative 8. So I don't need to do grouping. I can just say u minus 9, u plus 1 equal to 0, because this is just like a quadratic. Okay, I change the x to the fourth and x squared to something lower, so it becomes a quadratic. And then I split, right? And I will say u is equal to 9, u is equal to negative 1. Am I done? No, I'm not solving u. I'm solving x squared. So I have to do the last step, which is now solve for u. U is actually what? X squared. So replace this by x squared equal to 9. You have to solve it. So you have two more to solve. X squared equal to negative 1. But luckily, this is easy to solve because you just do square root and you would have x, right? Square root both sides. But on the constant sign, you have to do plus and minus. So x is equal to plus and minus 3. Again, this is square root both sides. Negative 1, square root, plus and minus on this side. So x equal to plus and minus square root of negative 1. Do you still remember what is square root of negative 1? Is I. So plus and minus I. So you have four solution. 3, negative 3, I, negative I. Okay. Do we have enough time? Yes. So let's do this one. This is also a quadratic form where you see terms, a group of ax plus b squared and a group of ax plus b. So what you do is you replace the ax plus b squared by u squared and the ax plus b by u. Solve quadratic and then solve again. So And in this particular example, I say the group is ax plus b, but actually any binomial terms would apply also. So let's look at this equation. This equation is x plus 1 squared minus 5 of x plus 1. It's the same term, right? This term has a square. This term doesn't have a square. So what you can do is, well, I'm just going to do u squared is x plus 1 squared. U is x plus 1. We call it substitution. Okay. So this equation now become u squared minus 5u plus 6. See, it was very clumsy, but this both are the same thing, and I replace it by u and u squared. Now it's very easy, so it seems like something that I can factor. So what should I do? What number? When I multiply is 6. When I add is negative 5. Is it factorable? Negative 2, negative 3, right? If I add them, that is negative 5. If I multiply them, that's 6. So it would be u minus 2, u minus 3 equal to 0. So then we split it as u equal to 2, u equal to 3. Am I done with my solving? Actually, no, because my u is actually not what my original equation is. U is x plus 1. So I replace this by continue to solve. X plus 1 equal to 2. X plus 1 equal to 3. So don't stop at u. X is equal to 1 because I minus 1, minus 1. Minus 1, minus 1. X is equal to 2. So these are the two solutions. Okay. So this works if you have two groups that are identical. One has a square, one doesn't have a square. The other one is when you have x to the fourth and x squared. And then you can solve it by doing u substitution, as if you are solving a quadratic. That is all for 2.6. So other equations is all done. So we have how many? We have quadratic form equation, we have absolute equation, we have radical equation, we have equation in exponent, so it's a lot of different equation. And then in 2.7 we'll solve inequality, and that would be the end of chapter 2.